ESF is the oldest, largest, and most distinguished institution in the United States that is focused on the study of natural resources and the environment. Hello and welcome to this edition of Improve Your World with SUNY-ESF. I'm Dave White. We're going to focus on trees and forest management, from how to properly plant a single tree to dealing with thousands of acres of trees. We start at the Heiberg Memorial Forest, located in Tully, New York. The 3,900 acres of forest and wetlands are used for education and research. A few years ago, managers spotted a serious problem that required a major intervention.
Well, this is essentially a salvage harvest of a 15-acre northern hardwood stand at the Heiberg Forest that was severely infested by the forest tent caterpillar, which is a fairly significant defoliator of sugar maple, which had resulted over the past 4 years of repeated defoliations in approximately 50% mortality. We lost about half the trees in the stand, and the other half were 50 to 60% dead. So the insect forced our hand. We had to come in and do something to try to salvage the value in the material that was standing there. And more importantly, what had occurred over the years is that the repeated defoliation resulted in sunlight reaching down into the forest floor, resulting in a tremendous growth of blackberries. The blackberries shaded out all other competition, all other tree regeneration on the ground. We have nothing there. So by removing the overstory, we're left with zero regeneration on the ground. So our challenge is try to bring back a new forest where we once had one before. And we're going to be doing a couple of different things in order to do that. First thing is to remove the remaining overstory, salvage the material that remains on the property, remove any hazards to health and safety. At the same time, we've applied herbicide to the existing raspberry. We're going to eliminate that. And now the challenge is, how do we get back regeneration? And we're going to be looking at a variety of different methods to accomplish that, everything from natural regeneration through forest planting. Most of the trees would have died in place, resulting in a significant hazard to health and safety of our students. It's much more effective to come in now, remove those trees, salvage what value we can in them, what's left in them. There'll be a variety of products. The logs are being processed into a variety of grades. Much of it will be sawn into lumber. Some of it, we might get some veneer logs. A large proportion of it will be sold as chips and or pallet wood. We anticipate a larger percentage of this material will be of low grade, low value material, just because the defoliation that had taken place over the past probably 4 to 5 years has resulted in highly stressed trees that were in many cases also invaded by insects and fungal diseases, bacteria. Much of the material has been discolored and a lot of decay has set in at this point, so we're not really expecting a tremendous value in return.
This harvest at Heiberg was done with some equipment unusual for this part of the country.
We're using an unusual equipment mix for this harvest for central New York. Most felling is typically done manually, but because of the inherent danger in this type of an operation where you're removing trees where the tops are 50% or more dead, we felt it better to use mechanized equipment that would provide an additional level of safety to the operator. So what we're going to be seeing is some equipment that we wouldn't normally see in a forest like this. Amongst the machinery is a feller buncher, which you'll see, which can pick up and saw an entire tree, pick it up, top it, bucket in the logs, and pile it all at once. Grapple skid, very large grapple skidder, which is unusual in and of itself. We usually use cable skidders in northern hardwoods. We'll see a slasher on the landing, which is used to process the logs. There are a variety of other pieces of equipment that will show up over the next few days. It's an operation a little bit more typical of our northern properties, unusual down here in central New York.
Once all the affected trees were cut and harvested, the teachers and students came in with a planting plan.
Since there was a limited amount of seed from natural sources, then the decision was made to plant the trees with conifers that are commonly used in New York State. And so the project here today is to follow through the clearing of the forest and the preparing of the site by planting of the trees. And they're planted out in blocks. So there's a block of spruce and a block of pine and a block of larch. And we'll repeat that 3 times across the site, planting each row from the top of the hill to the bottom of the hill. And each block will have the same species with the same species from top to bottom of the hill. We know pretty well where these different species will grow and how to manage them. We just need better opportunity to show that to students and to give them an opportunity, like you see here, of practicing tree planting, so they leave the college with that as a part of their experience.
This is a European larch. This is a deciduous tree. That's why some of them, it's not actually dead. The needles turn brown for the winter. And has more open canopy than most species. At least the American does, so I'm assuming the European does as well.
They run from about this size to this one was pretty long. It was about that deep.
Oh, okay.
So that's about all you want to cover. You don't want them too deep. They're packing them in so the animals don't pull them out.
These are students from the College of Environmental Science and Forestry and from the Forest and Natural Resources Management program. So they come from a variety of career interests. Some of them have been studying silviculture, forest management, others natural resources management and policy. It's just great that the students have an opportunity to come out and participate this as a legacy for the future and also to get some experience along the way. We want to make this to ensure that there's a good forest developing here into the future. Now, one of the uses of this property is for demonstration and teaching, and part of the instruction involves helping students understand how to select the proper species for tree planting. So that's the purpose of this exercise, to establish Norway spruce, red pine, and European larch, and to show through time how they grow and develop from a well-drained soil here where we're standing to a poorly drained soil at the bottom of the hill. And we would expect then that the different species will not grow equally well across that range of soil drainage classes. We want students to learn that if they choose the wrong species, it will fail in the long run, and that will cause more health problems into the future. So up here at the top of the hill, all 3 species will grow quite well. Norway spruce and larch will grow quite well down through the middle of the slope, and at the bottom only the Norway spruce will grow. So we will be able to show students in the future where each of the 3 species succeeded and failed, and link that to soil conditions, and thus help them to make better choices in the future.
This is a long-term education project, and it will take many years before the differences in what was planted where will show up.
We will certainly check the survival rate by the end of summer, and then periodically after that. But we'll primarily in the first few years just show students the range of site conditions, because differences in the growth of these species won't become apparent at first. The red pine will probably grow reasonably well here for 20 to 25 years and then begin to fail. And the larch probably would go a little longer than that. So this is a long-term project to help students who will be coming here in 10 and 20 years in the future.
After 6 months, ESF Forest Properties Manager Bob Davis assesses the success of the planting.
We couldn't be happier with the development to this point. We did have some mortality of red pine in the rows. It tended to occur in contiguous strips, and we suspect that it was largely because we had planted dead trees to begin with. They had had some trouble with the cooler at the nursery this past spring, and we think that resulted in some seriously moisture-stressed trees when they went in the ground, and that we ended up likely planting dead trees to begin with. We'll do a reinforcement planting this spring and make sure that we get 100% survival of the pine.
As the new trees get started, efforts are also underway to prevent the blackberries from taking over the ground cover.
We did do a recent treatment with 2,4-D to release the planted pine to control the broadleaf vegetation, and it seems to have worked wonderfully. We're going to probably follow up on that at least one more year and possibly 2 to make sure that the planted trees are off to a good start. The larch have done tremendously well. They're up around 2.5 feet in height at this point. And the spruce and the pine that didn't die have probably grown at least 6 inches over the summer. So we're thrilled with the development that we're getting. The idea here was that the teaching tools that our faculty will have at the forest 20, 30, 40 years from now will depend upon the conditions we create today. So this planting will actually, the demonstration value of this planting will actually come into its fullest in about 20 to 40 years. It'll have some value before then, to be sure, but it'll make an outstanding teaching tool for the next generation of our faculty.
As for the wood that was harvested from the afflicted acres, it was pretty low quality.
However, the revenues that were generated went into improving the road into the stand and covered the cost of the planting. So in the end, it was a wash, and we're reasonably happy with the way things turned out.
We'll have tens of thousands of stems of willow growing on this field, producing biomass year after year. Anywhere that wood is going to be used to generate electricity or heat, or also the process now of making ethanol from cellulosic materials. Wood will be one of those cellulosic materials, and so willow biomass crops will also go into those markets to produce ethanol and also heat and power. And so this just fits into the whole thrust that ESF has and continues to move forward with in terms of developing renewable energy systems.
Now we move from central New York to the heart of the Adirondack Mountains and the Huntington Wildlife Forest at the ESF Adirondack Ecological Center in Newcomb, New York. A research project is underway to bring back the tree that built America, the white pine.
It is the tree that built America. When the colonists came in the 1600s, they used white pine to build almost everything. Houses, bridges, everything. The white pine were all over. They were huge, and it was the major construction wood. It was light, it was durable, easy to saw, and so it was really what they needed. So it does have a rich history, and it is my favorite species. I'm not shy about that.
Also in that era, the white pine was a British favorite for the masts on their sailing ships because the tree grew so tall and straight. But gradually the white pine gave way to the northern hardwoods that we see everywhere.
It's been a gradual process, and in the proposal I actually wrote that white pine surprisingly has less than 5% of the forest cover in the whole state of New York. When you drive through the Adirondacks, people have said that they doubt that number, but you have to consider that most of New York is northern hardwoods, and that white pine is fairly rare, at least in the southern tier, and that the only time you see it is when you're in the Hudson Valley, the Ausable Valley, where those sandy soils are. And otherwise, it's just a scattered species.
But this stand of white pine is very different, planted in 1916 on very good soil and maintained throughout the years. Many of the trees have grown 140 feet tall, 25 to 30 inches in diameter, and ready for harvest.
The result of the harvest up at Huntington, the white pine harvest, has been mixed. The story is a good one, but we are learning some things that we weren't expecting. That although the trees are tremendously tall and big and impressive looking on the stump, we did find more red rot when we cut the logs than we expected. And when we did the yield study up at Ward Lumber, we don't have the final results on that yet, but I think we're getting more lower grade standard lumber, industrial lumber, than we expected, primarily because of the black knots. These trees, the first log of each tree was pruned many, many decades ago. So those butt logs are producing select and finished lumber, and that was unbelievable. The boards coming off the head saw at Ward Lumber were literally 18, 20 inches wide, of pure white wood that is the highest grade possible.
But you can only prune so far up the tree, so the quality of the wood further up the tree drops substantially.
This is what happens in research. You have expectations, or even as a forest manager, you have expectations of the quality that you're going to get from your trees. And, you get little surprises like this. Again, the good surprise was it was just unbelievable to see these butt logs being cut, because they were as impressive as we thought they would be. But it was disappointing to see the low grade coming out of all the other logs. The butt log is the first 16, 17 feet from the ground up. So this is the most, this is where the tree is going to put on its girth. And so the reason we prune these trees early in life is so that as the tree puts on more girth as it grows, those branch scars that were cut off many, many decades ago are going to be hidden in the middle of the tree. And all that wood that grows outside is going to be all knotless. And that fetches the highest price in the market. So one of the papers, or at least results that's going to come from this study, is that it pays to prune. No one prunes anymore because they perceive it as too expensive. But we're going to do some financial analysis of the grad student on the project, and we are going to determine that we're not sure yet, but that the cost of pruning certainly is going to equate to higher yield down the road. So if you put a little investment in pruning when the trees are young, pole size, 10 inches or so, 30, 40 years later, you're gonna get much nicer lumber. The reason that this stand is so special is because it's one of the few white pine stands that's actually growing on high quality site. It's not that you don't see white pine all over the Adirondacks and the Hudson Valley, but when you see it and you go into the stand and you start kicking around the soil, you're going to notice that it's a sandy soil that the white pine's growing on. And so the point of the research is to investigate whether it makes sense to try to manage white pine on high quality sites. Are the yields going to be enough to pay for the management costs? And in order for us, and so that's going to be the long-term part of the research, is in order to get white pine to grow on these sites, we're going to have to use herbicides to get rid of the hardwoods and the ferns and the shrubs that are going to come up naturally and outcompete the white pine. So, and we're going to have to scarify the soil, because the white pine seed needs a scarified soil to germinate. So those are all things that you're going to have to, do intensively to invest in the site to get white pine back. Is it worth it? We don't know the answer to that question right now. We know that we're getting impressive yields from this particular stand, but the point of the research is to let the rest of the managers of white pine know whether it's worth it to invest in these high quality sites to grow white pine. The remainder of the research is going to follow how well the seedlings do that we either plant, seed, or come up naturally in the coming decades, and to see how they come through the canopy, see how they compete with the hardwoods, and so it'll be, and we have photo plots that we're going to take photos every year or two to monitor what this stand's going to look like. So it's going to be really cool for research purposes as well as outreach purposes, since we have the Visitor Interpretive Center right across the street. So we're able to take the general public through these areas to teach them about forest management, to teach them about regeneration, to teach them about sustainable management, and that cutting trees is not a bad thing. It's all part of the process. We use lumber, we use paper, and so the idea is to manage a renewable resource.
Arbutus Lake is a relatively productive lake, and we kind of believe that probably other sources of water going into the lake, other inlets, would be fairly close to this based upon what we've done in some chemical balances. We are using this stream to look at how changes in atmospheric deposition, changes in acid rain, changes in the climate, droughts, different changes in the winter, how this affects the stream's hydrology as well as the chemical responses. There are times, like after a period of drought, you have conditions in the watershed which actually produce acidity, so you can have pulses of acidity which are very deleterious to the biota that occur within the site under certain types of conditions. And we're also looking at the water going out of the lake, so we can also look at how the lake itself affects some of these processes. And we also can link this to some biological changes in the lake as well as biological changes within the stream and associated terrestrial system, the trees and the soils around the stream. Now we go from acres and acres of trees to planting and growing just one tree in a very special location, perhaps your backyard.
This is our introduction to arbor culture, and today we're going to learn how to plant a tree. I imagine how many people here have planted trees at one time or another? Little ones or big ones? Okay. That's great. I'm very glad to see that. There's at least two things that I think everybody who graduates from the College of Environmental Science and Forestry should know how to do. Plant a tree and cut down a tree. There's been a lot of research done in the last 25 or 30 years on growing trees in pots. You'd think that'd be a fairly simple thing. People have been growing various plants in pots for many, many, many decades, and yet we come up with this tremendous variety of pots. So these are foresters type plants where you're planting 1,000 trees in an acre. You're planting them in pots like this. If you're arborists and you're planting trees in people's yards, you tend to grow them in larger pots. You grow them to larger diameters, and you don't plant 1,000 of them per acre. This is a flower pot. It's got drainage holes in the bottom. That's better than some pots. You ever find a pot that doesn't have drainage holes? Just don't even bother. What's wrong with these pots for growing trees? Smooth surface. What's going to happen when you put roots in those? When you put something in that pot, what's it going to do? You have circling roots. You see where this thing was in a container, you can tell just exactly how big that container was. Even if this thing had been in the ground for 4 or 5 years, all that happens is these roots grow bigger and this trunk grows bigger, and eventually the thing will hang itself. When you're planting a tree in the ground, how you aim the roots is very critical. You can half or double the life expectancy of a tree when you put it in the ground. This looks like a regular circular pot, but if you see the inside of it, it looks like this. You've got these ridges, and you've got these little holes. So what will happen is the tree roots grow out to the edge of the pot, and they circle around, then they hit a rib, and then they go down, they hit another rib, and then they crawl out this hole, and then they air prune off. See all those holes? This is all holes. You've got all these little, so each one of these, you've got mineral deposits from the fertilizer in the soil and from the hard water. But let's take this one apart. Now look at the ridges in that. That was going to get those roots. They were not going to spiral. That pot is determined to point those roots away, and it's done a beautiful job. All the roots are nice and loose. All the roots are aimed away from the trunk. This is great. This is a perfect example. How long has this thing been in the ground, in the pot? 2 years. Okay, look at this pot. Look at this pot. What do you see in that pot? Not enough holes, no ridges on the sides. And what'd you get? Look at these roots. Look at those circling roots. So what you do in this case is you cut into the root ball. Am I killing these roots? You betcha. Is the plant going to grow more? You betcha. Second one is you got to dig a big enough hole. You always dig wide, not deep. It's much more important that you have at least twice the diameter of the root ball that you're putting in the ground. You should have a hole at least twice, and sometimes in heavy clay soils you want at least 3 times that diameter. You feel ridiculous when you dig this. You get a big wide hole about the size of a bathtub, and you put in this relatively small tree, but it really makes a big difference. That tells you how deep you want it. We're just about there, good Lord. You've got to have the roots so they're right at the surface when you're finally finished and the ground is settling and the tree is in its final position. The topmost root should be right at or even just slightly above the surface of the soil. Even such little things as whether you have the very slick sides on the hole. You scratch up the sides when you plant the tree. I've seen trees planted with huge augers. It slicks up the sides of the hole, and those roots will grow out to that point, and then they won't penetrate into the original soil. If you slant the sides of the hole, you have what's called a rain gauge effect, where you've got the outside of the hole, it collects water, so it puddles down in the bottom. You can drown your tree. You can either double or half the life of a tree on the day you plant it. So if you do everything right, most trees will grow for the best part of a century. Even fairly, quote, short-lived trees will grow for 50 or 60 years. If you loosen the soil up, if you've got the right soil mix, if you've got all the roots pruned off that are going to eventually would otherwise circle the tree, that tree may last for decades longer. What's the first rule of pruning? Dead branches. Okay, this one's mostly dead, and this one looks to be dead. You want to take off all the dead branches. A lot of times in the nursery stock, you get winter kill and things like that. So you freeze back the top 2 or 3 inches of the branches. They'll just look ugly. They don't hurt anything, but they look ugly. So you cut them back to a live bud. You also want to cut them back to a bud that's aimed the right way. If you've got most trees have buds all the way around the stem, and if you leave the bud to the outside, that top bud on the branch that you leave behind is aiming out, the branch will continue to grow that way. If you cut them all to where they're aiming in, then you get this tangle of branches forming into the crown of the tree. So a lot of it is where you leave the buds. These are competing leaders. If you just let this tree go, both these will take off, and both these will fight for 25 years to decide which one's going to be the leader. As soon as you see 2 branches that are forking, even if they're just tiny little branches, a pinky finger diameter, you clip one of them off. Basically, if you've got a fork in a tree low toward anything under 10, 15 feet above the ground, this is a bad thing, because both of those stems increase in diameter, they start pushing each other apart and they split. Also, they rub against each other if the wind is blowing, and they're pushing and rubbing and pushing and rubbing. The bark in the cambium on each of those stems is crushing itself, so it eventually dies, and then you get leaves and sticks and crud in there, and it will rot. And so one of those stems is going to blow out before in a heavy storm, and you see that all over town. You're going to do a reduction cut on this. So what's that? What's a reduction cut? Well, they call it a reduction cut because you reduce the growth of that particular branch. If you've got a small diameter trunk and a fairly large diameter branch, if the branch is more than 1/3 of the diameter of the trunk that you're cutting it off of, or a smaller branch on a bigger branch, you don't want to cut it off yet. You can't make the branch any smaller, but what you can do is grow the trunk bigger before you cut off the branch. They call that a reduction cut. You cut the perfectly good some of the foliage, maybe 1/3, maybe even half of the foliage off of the branch that's going to be on there temporarily. It feeds itself, but it doesn't get much larger. It feeds the rest of the photosynthate it makes down into the trunk of the tree, so it gets larger. And then maybe 2 or 3 years down the road, you've got a 6-inch diameter tree with an inch diameter branch, and you can cut that off much better than if you cut off a 3-inch diameter branch or an inch diameter branch off of an inch diameter stem.
That's it for this edition of Improve Your World with SUNY-ESF. I'm Dave White. Thanks for joining us, and we hope to see you again next time.